Is multiplying a whole number by a fraction the same as multiplying a fraction by a whole number? Yes. No. Sometimes. In this video, we'll talk about when two expressions like this are the same and when they are different. Then we'll look exactly at how to multiply a whole number by a fraction. You're going to get the same product or answer. That's what some of your students or children might say as you're teaching this skill. But why? And what is the question exactly? If there is no context at all and someone is just evaluating these expressions, then yes, they represent the same thing. What about when there is context? Let's look at two examples of these expressions in word problems to examine how they are different. Here's our first word problem. Jason filled a container with 8 gallons of water to wash both his parents' cars. He used 1/3 of the water to wash the smaller car. How many gallons of water did he use to wash the smaller car? So in this example, there are 8 gallons of water, and we need to know how much 1/3 of the 8 gallons is. Let's represent this with a picture model. We'll start by representing the 8 gallons, or we can also think of them as 8 holes. Next, to show 1/3 of each gallon, we'll divide each hole into thirds, or 3 equal parts. Then, shade in 1/3 or one of the 3 equal parts in each hole. How much is 1/3 of all 8 gallons? Let's count. 1/3, 2/3, 3/3, 4/3, 5/3, 6/3, 7/3, 8/3. In this example, we started with an amount, 8 gallons, and determined what a fraction of that amount is, specifically 1/3 of 8 gallons. Based on previous work you've done with multiplication, your students or children will remind you that you can change the order of the factors and get the same product. But is this the same in context? No. Let's look at our second word problem to see how it's different. Jason filled a container with 1/3 gallon of water to wash both of his parents' cars. He filled the container 8 times to wash the smaller car. How many gallons of water did he use to wash the smaller car? Okay, we see the situation is similar. The numbers are the same, but something is different. Do you know what changed in this word problem? Yes, the size of the container has changed. In the first word problem, the container held 8 gallons of water. In the second word problem, the container holds 1/3 gallon of water, and now Jason has to fill it up a total of 8 times. Different, right? Now we are multiplying a fraction by a whole number. We can think of it as 8 groups of 1/3, or 8 times 1/3. Let's represent this expression with a model. We'll start this picture model by representing the 1/3 gallon of water. Then divide it into thirds and shade in 1/3. This represents Jason's container of 1/3 gallon of water. He has to fill it up 8 times. We'll represent that by repeating this model of 1/3 to show 8 total holes. The model looks the same. How we arrived at our result is what is different and really reflects how it would be different in the real world. Imagine if you were Jason and were tasked with filling 8 gallons of water into one container, or filling 1/3 gallon of water into a different container, then filling it a total of 8 times. It's a different experience. Going back to our example of 1/3 times 8, when evaluating the expression, just like multiplying a fraction by a whole number, we can multiply the whole number and the numerator, where the product is our new numerator. The denominator stays the same. Why? Think back to our models. We still had thirds. The number of thirds is what changed. 8/3 can remain as a fraction greater than 1, or improper fraction, or can be converted to a mixed number. 8/3 is equivalent to 2 2/3. I have a video on how to teach your students 4 ways to convert fractions greater than 1 or improper fractions to a mixed number. You will see that link in the description below. Let's look at an example together where the fraction is a non-unit fraction. Jason and his brother went to the store 6 miles away from their house. They ran for 2/5 of the way and walked the rest. How many miles did they run? An expression that we can use to represent this word problem is 2/5 times 6 because we need to know what 2/5 of 6 is. Since this word problem involves measuring a distance or length, we can also use a number line to model this expression. Start by drawing a line and marking the endpoints with 0 and 6. Then divide the line into 6 equal parts to represent the 6 miles. Next, divide each of the 6 holes into fifths. Then we can show arrows representing how they ran 2/5 of each of the 6 miles. You can have your students count by 1/5, 1/5, 2/5, 3/5, 4/5, 5/5, 6/5, 7/5, 8/5, 9/5, 10/5, 11/5, 12/5. Or you can have them skip count by 2/5 at a time. 2/5, 4/5, 6/5, 8/5, 10/5, 12/5. To just evaluate the expression 2/5 times 6, again, we know that we can multiply the numerator and the whole number, and the product of that will be the new numerator. Then keep the denominator the same, 12/5. 12/5 can remain as a fraction greater than 1 or improper fraction, or it can be converted to a mixed number. When you discuss if the expressions 6 times 3/4 and 3/4 times 6 are the same or different with your students or children, and the answer is both yes and no, now you know the why behind it and have different examples of problems and models you can explore with them.